All right, we're going to be going over some basic matrix operations today, including addition, subtraction, and some multiplication as well. Um, Basically, matrices are a way to organize values by using rows and columns. We give the dimension of a matrix in that order, rows and then columns. So for example, this matrix we see here, this is row 1 and this is row 2. This is column 1, 2, and 3. So this is a 2 by 3 matrix. It has 2 rows and 3 columns. The second matrix here has 1, 2, 3 rows and only 1 column. Another way that we'll give the dimensions is by calling the matrix a letter. A lot of times we'll just generically use A. We always use a capital letter for matrices. And then we'll just subscript the dimensions, 2 by 3 here. Maybe we call this matrix B. Therefore, we would say B is a 3 by 1 matrix. Instead of the word dimensions, you'll also see the word order used as well. The order of the matrix is its rows by columns. So one of the simpler operations that we'll do on matrices is addition. You're basically adding what are called corresponding elements. Each of the numbers in the matrix are called either elements or sometimes entries. I usually refer to them as elements. So we're going to add this element here with that element there to get the corresponding element in our resulting matrix here. So I'm taking a let's just so we get a little practice at our dimensions here, our orders of this matrix of these matrices. We're adding a 3 by 2 plus a 3 by 2. Well, that means we're going to get a 3 by 2 in return then. So we're going to understand what the size of our matrix is going to be. So my handwriting is a little bit bigger than this type, so I'm going to get a little bit bigger here. So we're going to take 5 plus negative 2, which is 3. And then I'm going to move to this spot right here. So I'm going to take the negative 3 plus the 1 to get negative 2. Hopefully I don't make any mistakes here because I'm going to try to go fast. Negative 3 plus 3 is 0. 4 plus 0 is 4. 0 plus 4 is 4. And 7 plus negative 3 is also 4. I'm just going to do a real quick scan here to make sure that that's right because I left my key at school. Looks good. All right, and if I do make a mistake, I'm just going to keep breezing through it and we'll fix it later. Order of operations stay the same with matrices, so I'm going to take care of the stuff inside the parentheses here first and add those two matrices together. So I'm just going to rewrite that first matrix, that first 3 by 2 matrix, and then on the inside of that parentheses, I'm going to combine those two matrices. They're both 3 by 2, so I know I'm going to get a 3 by 2 in return. And I got rid of the parentheses since I'm combining them already. So we're going to take 9 and negative 7, which is 2. Negative 1 and 4, 2 and 5, negative 3 and negative 1, 3 and 3, and 8 and negative 2. I think those are the right values there, and then we'll just go ahead and now do subtraction. So obviously you got to be careful. If you want, you can distribute that negative to all the terms and turn it to a plus sign. I just like to literally look at it and say, what's 3 minus 2, and then put that answer in the resulting matrix. So here's going to be my final answer here. 3 minus 2, 2 minus 3, negative 2 minus 7, 0 minus negative 4 would be 0 plus 4, 1 minus 6 would be negative 5, and 6 minus 6 would be 0. All right, this here is called scalar multiplication. This is a scalar when you're multiplying a number to a matrix. We're going to distribute it like I think intrinsically a lot of us would. It's called a scalar because this is often used to scale dimensions of shapes that we put the coordinate points inside of a matrix. We can scale that shape, make it bigger or larger by changing this number out here. So we're just going to distribute this in, which is called multiplying by the scalar. So we're going to have 6, negative 3, negative 9, and negative 15 there. So obviously you just got to be careful with your negative signs. All right, this is asking us to take 2b minus a. So look at your matrices here, 2b. So I'm going to take 2 times that matrix. And if you want to write the whole thing out, here's what it's saying. 2b minus a. So I just rewrote it with the actual matrices in. Okay, make sure I copied everything right. And then we're going to do our scalar multiplication first. So you have to do that first. So we're going to have 36, negative 24, negative 12, and 0. Still subtraction. And now 36 minus 5. Negative 24 minus negative 4 is negative 24 plus 4. Should be negative 20. Negative 12 minus 3 is negative 15. And 0 minus negative 1 would be 0 plus 1, which is 1. There we go. This next one we're going to skip just for time purposes. You would do the scalar first, then you would add those matrices together, and then last you would do the subtraction. Okay? But just for time purposes. I just want to point out these are all 3 by 3 matrices, 3 rows, 3 columns. All right, solving matrix equations. We're going to do some equations with matrices to help us solve systems later. This is not there yet. These are actually pretty simple. What we're going to do is find where our variables are and set up an equation accordingly. So here I see the x's in that spot right there. So if I take all the other corresponding spots, okay, I can set up this equation using the minus and the equals there. So we have 2x minus 3 equals 5. Okay, now we just solve. And there's the value of x. We could check it, put it back in. If we put it back in, we'd have an 8 here in this spot, right? All right, so if we had 8 minus negative 3, that would be 8, minus, see, this is why we check our answers. Let's go back here. Try that again. 2x minus negative 3 equals 5 would be 2x minus negative 3, there we go, equals 5. And now we can subtract 3 and get 1, divide by 2 and get 1/2. Always got to check your answer. So if we plug that back in, we get a 1 right there. 1 minus negative 3 is 1 plus 3. And I've made a mistake again here somewhere because that's a 2. There we go. There. 2 minus negative 3 equals 5. Looks good. I'm just so excited to get to the matrix multiplication here. I'm going too fast. All right, this one looks a lot more complicated, obviously. Let's see what we get when we set these equations up here. X plus 2y. So I got that one plus that one equals 5. Okay. And then I'm going to do that now with the second row. I have 0x, excuse me, plus y plus negative z, so just minus z equals 3. And then the last one is just 2z equals 6. So we have a 3 by 3 system. This is our first 3 by 3 system. 3 equations, 3 unknown variables. But it's set up pretty nicely for us because of that guy right there. We can easily solve for z. By dividing by 2, and now we have one of our 3 variables, and we could put that back in to find y. So we know that y minus 3 equals 3, so y is 6. And then we can put that back into there, along with the z back into that spot. So we have x plus 2y, which is 12, plus z, which is 3, equals 5. So we have x plus 15 equals 5. X is negative 10. So we just solved that system. We're going to give this, usually if we have x, y, we can give it as a coordinate point. Well, here we have what's called an ordered triple. X, y, z. There are 3 answers there. All right. Just for time purposes, I am going to stop there and we'll create another video for matrix multiplication.